So we are going to do the titration training. For this system, the system is from Titrator Toledo, and first I'm going to cover what are the fluids we have in the system, or we're going to use in the system, whether for calibration or as a carrier fluid for our crude oils or as titrants. So before we go into details about the system, so for calibration, we have pH buffers. So we have a pH 4 and pH 7, and we have another one for pH 10. But generally, we have like larger bottles than these. We are just using those for samples or pH buffers that we have used before. Generally, pH buffers are reusable, so we can just store them in the fridge after the calibration, and then next time when we need to use them again, we bring them back and use them, and then we make sure from the millivolt that will come out, or the pH that's going to come out, whether the pH is accurate or not accurate. If it's accurate, we can keep reusing them until they go bad, and then we use a new batch of pH buffers. So we use those buffers for calibration, and this is one of the first steps we are going to do in the titration. After that, we will either measure acid number or base number. So if we measure the acid number, we will need potassium hydroxide, which is this bottle. And if we measure base number, we need hydrochloric acid in isopropyl alcohol, which is this bottle. We have a couple of other solutions, which are the lithium chloride in ethanol and lithium chloride in ETOH, which is this one. So the big bottle, we just use it to store the pH sensor, as you can see probably here, like in this small cylinder. So generally when we safe keep our pH sensor, we keep it in this container, as you can see here. So here we put like 50% of this solution with isopropyl. The second bottle, or the second solution that we're going to use is also lithium chloride in ETOH. This one we put inside the pH sensor itself. So we have to change the solution inside the pH sensor each 3 to 6 months, depending on the usage of the system. So generally this is something that the person or the contact person has to do on his own, so you don't need probably to worry about this. So after that, we can start the calibration directly, but you will need to prepare some solutions also on the side. So you will need like 50% isopropyl alcohol and toluene. So you have isopropyl alcohol and toluene 1-to-1 percentage. Like try to prepare like 1 liter of it, because you would probably consume all of it in your experiment. And they have to be fully mixed. If they are not, something is wrong, and then you have to one of the solutions is probably bad, so you need to find another source of this solution. So the first step should be the calibration, but I'm not going to start with this because the system now has HCl as the titrant, and I want to measure the acid number. So I want to change from the HCl to the potassium hydroxide. In order to do that, I need to empty all those lines going to the titrant bottle, which is this brown bottle. I have to change all the HCl from there with potassium hydroxide, and this is what we are going to do. So our system is composed of the pH sensor, as you see here, and this is the safekeeping cylinder for it, plastic cylinder. And then we have a fan. We have this line coming from what we call a burette. A burette has a titrant in there, and it takes this titrant from the brown storage. So whenever you use the system, try to update us with what solution is inside the brown bottle by a sticker or anything, and write on it like it has HCl or KOH, so that the next user is not confused what titrant is in there. So in order to do that, we have to take this apart. So we will take this burette out, and then we will remove the piston from this orange cylinder, and we'll try to drain everything into the brown bottle. So I'm gonna do this right now. In order to do this, I have to, you see this blue knob, just rotate it counterclockwise to free the burette, and then pull it out. So when you pull it out, try also to pull its end going into the right hand side out. Then we'll pull the piston. We'll pull this piston out. See here, just by hand. Okay, it's not going out. It's not coming out. Stop the video. So if the lines and the burette still has any solution, it will be very difficult to take the piston out, so we have to cycle air throughout the lines in order to empty everything out. That's one way to do it. But this way we will probably lose HCl in the burette and in the lines. But another way to do it, we can also, when we cycle air, we can have the discharge line here in order to save the HCl. Just place it here. And then we do a rinse. So how to do that? If you can see our screen. So if you can see our screen here, you click rinse, and then you do like 3 cycles, so that it will take from the inlet and discharge from the outlet, and both of them will be in the HCl bottle. Just make sure that both lines are not going into the solution. So here it will just ask you what titrant this is, so just choose your titrant, which is HCl and isopropanol, and do 3 cycles and start. So you will see the piston is going up, pushing all the HCl, and it's going out there in the HCl storage. So it will do this 3 times until there is only air. So you can see air is actually going in from the line, from the inlet. And now we still have both HCl and air. So probably in the second cycle, 2 cycles are probably enough, but just do 3 just in case. Okay. This is how you change or how you drain the lines from your titrant. Now the idea is to add a new titrant, so we will just remove the HCl from this bottle and we will clean it thoroughly with probably DI water is enough, but just do it several times so that it's completely clean, so that you don't have a mixed titrant in there. And then we will fill it with potassium hydroxide for base number, for acid number measurement. So we'll stop the video and come back after we have the acid number in the the KOH in this bottle. Okay. So now I changed the titrant in this bottle into KOH, and in order to clean this out, as we said, we did like the 3 cycles, and then we took our glass bottle out, and then we took the piston out of here, and then we cleaned it with water, and then you put it back. Taking the piston out could be a hard task, so it may need a little bit of force, but try not to break it, because we don't have any extra parts. In the end, after you do this, you need to adjust the height of the piston. So in order to adjust it, you need to use the cover of the bottle. So you just add this in it, push. So you add this in here, and then you push until it can go into the slider. Yes. So it can go in and out. Then the height of the piston now is okay. After this, you take this part and put it in position into the system by sliding it here until it's parallel to this. Once in position, you rotate the blue knob clockwise, just slightly, like you don't need to put too much, just finger tight is good. And this is not gonna move anymore. So, and then you take this part and put it inside this port so that it can go beside the fan. And you take the other part and put it inside your titrant. Just make sure it doesn't drip any HCl inside the KOH. So now we will cycle make sure also once you put it in here that it goes down to the bottom of the brown bottle, and then we will do a rinse. But before doing a rinse, make sure you have a waste cap connected to your system until it ticks, and then you do a rinse of 3 cycles. Choose the titrant. This time it's KOH, potassium hydroxide in ethanol. Choose this one, 3, and start. Okay, we're getting an error. It says the system is occupied with another titrant, so we need to update it. Okay, let's just for the sake of this, we use HCL and isopropanoid. Let's start because we need to do the cycle and then let it know what is the new titrant. So now I just didn't figure out what titrant is it, but because there is no titrant in the borate, so I just use the older titrant to do the rinse, and then we can do another rinse with the new titrant. So the idea of the rinse is to fill all the lines with the new titrant and clear anything else from the cleaning or from the previous titrant. Any residue, it will just be swept away. So now it will do 3 cycles. And yeah, now it finished the first cycle. It's running the second. So until now it's just cycling here. Make sure also there is no leaks, so all lines are connected properly. Because if any line is not connected properly, it's just going to cycle air. Now it started to get HCl, KOH in the piston. Probably in the third cycle we'll have to do like 1 or 2 more cycles just to make sure there are no bubbles remaining in here. Okay. So I think we can stop now and come back after the rinse. So now it finished the rinse. We just need to make sure there are no bubbles in the lines. You can just check it by the flash of your mobile. After that, take this waste crap away and try to clean here with distilled water. But also you need to take your pH sensor and put it in here. So, but before that, you need to make sure of one thing. Take it out. So as you can see, the lithium chloride level has to be up to here. This is the weird bottle I showed you before. So if it's not up to the glass slider or this intransparent glass, then you need to fill it with this one. So, and in general, when you start your experiment, also you need to keep this cap open during the experiment. After you finish, you have to close it back. So one more thing, you can also check that this glass slider can rotate. If it's rotating, that means it's working fine. If it's not, then you close the cap and put it upside down and then move it and then wash this area with distilled water and then put it back. Do this and then shake it a few times to make sure there is no air bubbles inside. And then open the cap again for your experiment. Okay? And put it back in here. This time we don't put it in the reservoir. We put it so that it can go into the cup along with the other lines. So there's a port of opening here. You just put it through it. And then connect it to the electric cable again. Once you connect it, it will detect it on the screen here, as you see. So it will tell you the detector is detected, you say OK, and you are good to go. So now we just need to clean this area that has been subjected to KOH with distilled water, just to make sure they are clean. So you just put a cup like that and start rinsing it properly. And never touch anything in here with skim wipes or any type of wipes because it will destroy the pH sensor and the fan, and just it's okay to leave it with droplet of water on it. That's fine. So next step would be the calibration. In order to calibrate the system, we have 3 pH buffers: pH 4, pH 7, and pH 10. And generally we have like new, as I said in the beginning, we have a new batch of them, like in this pack. But we will keep reusing them until they go bad. So don't try not to use the new ones because we don't have much of it. So just keep reusing those until one of them goes bad, and then we renew it from the new batch. So get new caps. Start by the pH buffer of 4. But before that, I just want to make sure one thing. Titrant. I want to make sure the system is detecting the titrant. So our titrant is KOH methanol. So we can do a quick rinse with 1 cycle and see what's going to happen, if it's going to detect it or not. If not, then we have to let it know what's our still not detecting it, so somehow it will detect it. Can stop now until I finish. When it's not picking up the right titrant, what you are gonna do is turn off the system, turn it back on. So that's what we're gonna do. We're just gonna turn it off, wait a few seconds, and then turn it back on again. So when you turn it back on, it should start picking up the sensor, which is, you will find the name of the sensor, pH sensor written on it, DGI116. So it will ask you, is this the sensor connected? You will say yes. You will say yeah, okay, this is the sensor detected. And then it will ask you, is the correct filled with KOH and isopropanol? You will say yes. If it says HCl, even though you change the titrant, then you can assign the current titrant by pressing assign and then choosing your current titrant, which is potassium hydroxide in isopropanol. Why can't I see it? So if you don't find it still, you can go to setup, chemicals, titrants, and then find your KOH and isopropanol and save. And then you go home and your titrant is. So now we just do the calibration. So in order to do the calibration, now we have cleaned this with water. So in a cup, we will put the pH buffer of 4. We need 60 mils. So every time you put a cup in here filled with something, it has to be 60 mils. And you will find that those cups are graduated, so you can just put your titrant up to 60 mils. And it shouldn't be less than 60 mils because it will not cover the pH sensor, and this is going to be a problem for your measurements later. So you put your cup back. And then on the screen you will have a cal option. So you have two cals actually, so we'll keep using the one on the top. This is the right method. So press calibration, and then it will ask you for the number of buffers. You have 3 buffers, so you can just start. It will tell you to add the first sample. You already added it, so just click OK and wait. After it finishes the first sample, you just remove this cup and bring another cup with the second sample, and in between samples you have to clean it with DI water. Also make sure nothing in the cup is touching each other, so the line is not touching the fan, is not touching the pH sensor. So it gives you like a quick curve like this. You don't click OK until you remove your sample, clean everything and put your new sample. In order to preserve this pH, you just put it back in its bottle and put it in the fridge. Now we have our pH of 7. So as you see, this one is a little bit less than 60, so we can add a little bit more from the storage that we have. So that it goes back to 60. Now we need to clean this with water, so bring your waste cup and start cleaning it. Thoroughly. Now we get a new sample, put it in. Nothing is touching each other. Start, click OK, and wait one more time. So we always do it from the lowest buffer to the highest, lowest pH to highest pH. Now it finished the second sample, so just remove it. Back in its container. pH solution. Clean DI water. Buffer. Okay.
So in the end, you look at the value of 0 cal, it has to be between 6.7 and 7.2, which is quite close. And also the slope cal has to be between minus 55 and minus 59. So that should be fine. That means your system is calibrated. If not, you probably need to check each PHP buffer on its own. And if one of them is not okay, you have to throw the one you used away and use a new batch and keep the rest as they are. So now we will see how to check each of them. So now we click OK. OK again. One more time. Then you go to results. And then all results. Train. Results. Samples, and then you have the 3 buffers. So you click the first one, you click data, and then you see your row results. It will give you the MV value, which is like 149. 149 is pretty low for the first PHP buffer, so we have to change it with a new batch. That means it's not good to use anymore. It has to be around 177. So down to 160 should be fine, but 149 is not good. So we have to change this one and redo the calibration one more time. Let's check the second one as well. For the second one, we have minus 17.6, has to be 0. So also like plus or minus 10 around 0 should be fine. Since it started changing, then we have to renew our PHP buffer. And for the third one, is okay because it's around minus 183. It should be minus 177. So that value is fine. So the third buffer is okay, but the first and second one need to be changed. So we have to do that and we do the calibration. So we redid the calibration with actually the same pH buffers without changing them. This time they are better, the values are better. And also the slope cal, as we said, is between minus 55 and minus 59. And the 0 cal is between 6.8 and 7.2. So click OK, and we'll go and check the results. From here, results, and then results, samples, click on one, data, row results, and you have this time 162.5, which is fairly close to 177. If it goes below 160, then it's a problem. And then we go back to the second one, and now it's like minus 11.8, which is close to 0, so it should be fine as well. And the last one is minus 180, which is close to minus 177, so also it should be fine. So now the calibration is done, we just go home and we start our sample. First things first, we need to do a reference. So our reference will be a 50% isopropanol to 50% toluene, or 1-to-1 percentage. A 60 ml of this, and then we will run it as our reference or blank acid number. After that, we will run our sample, and I'll tell you how to prepare the sample. So just need to take this off, clean the system, and do it. will add like 60 mL of our solvent, which is 50% isopropanol, 50% toluene. Try to be as precise as you can. So I washed here with distilled water before I do anything else. Put your cup in, and then you go to blank acid number, and you just start. Let's say add the sample, I already added, and wait. It takes a couple of seconds before it starts showing you a curve. So the curve here is going up, but if you are doing the base number, it's going to be going down. It would be the completely opposite. Okay, so this is what you are looking for. You need R1 to be not a number, which is your equivalence point, and R2, which is the end point, to be less than 0.2, or ideally less than 0.1 millimolar. If this is the result you're getting, then you are good to go. If not, you probably need to change, redo your reference measurement or blank as a number. But since it's good, so we can continue. So I click OK. Okay. And now we'll just remove this and put our sample in and see or measure the acid number. Okay, stop. So after the reference, we need to clean with isopropanol just to take the toluene out. And then with water. And then based on what you are trying to measure, you will find now we are trying to prepare our sample. So our sample is going to be a few grams of our crude oil put in a 60 ml of our solvent mixture, which is the 50% toluene, 50% isopropanol. So we will prepare like 60 ml of this solvent and put our crude oil in it. How much crude oil? It depends. If it's a base number, so the crude oil that we're going to add is 7 divided by the expected base number, and you will find it in the SOP. And if it's an acid number you're trying to measure, it also depends on your expected acid number. So you will have like a table, and based on this table you will decide which mass of oil that you need to add to your 60 ml of solvent. So in our case, we're expecting a very low acid number, so we added 10 grams of crude oil to the 60 ml of solvent, and then we are going to test that. So let's add it in here. So you attach the cup, you choose total acid number or TAM. It will ask you for the sample ID, so you can call it with its whatever ID you want. Click OK. And the sample size was 10 grams. And try to be precise in here. If there is any fraction, just add it. In our case, it was precise, so we just use 10. And you click start. It says add the sample, so we added the sample. Then it will start measuring your or showing you the curve of the measurement until it finds an inflection point, which is your acid number. If you miss your inflection point, that means you added less oil than you should have, so you increase the volume of the crude oil. If you added 10 grams and you still missed the inflection point, you then add 20 grams and repeat. So in our case, it didn't find an inflection point, which means once you get the R1 is not a number and the R2 is very low number, that means your acid number is below this value and is probably below your detection limit. If you try to add more oil, actually we added the maximum amount here in the table. We can still increase it, but I don't think we are going to reach anything else. The acid number is lower than 0.011. So your acid number should be the equivalence point, but since it's not detecting anything, we are going to say report that it's just lower than 0.011. And that should be it for the measurement. Once you finish, you need to take this cup out. And if your crude oil is heavy crude oil and it's leaving marks, you may need to use your solvent mixture. Put 60 ml in a cup and put it here and then do a stir. How do we do that? We just do one for observation. Okay. So add 60 ml of your solvent. Try to clean it first. Size of propanol. We take as much oil away from the sample. Then you add your mixture. So you go to manual, stirrer, and then you choose the stir time and speed, click start, and then it will stir everything. This way you make sure your pH sensor and everything is clean, and then you take it out and you rinse it with isopropanol and followed by water. So it's done, click OK, you go back home, and then you remove your clean one more time. After cleaning, you will need to take your pH sensor out, close the cap and put it back in the safekeeping cylinder. Take it out, close the cap, put it in here. And last things last, you need also to you will need to safe keep your KOH, because if you left it like that, this is what's going to happen to it. It will be like this, despite that the original color was something like this. So we don't want this happening in our brown bottle because it's going to be difficult to clean it. Like you'll have a residue deposited at the bottom. So whenever you use KOH, you have to take it out of your brown bottle and leave it clean. So just put it in another bottle similar to this one and put it in the fridge. If anyone comes to use it and it's empty, then they have to fill it similar to what we did in the beginning of the video. And in the end, you can also take your data, save data from the flash drive on the side of your of the system, but make sure to return it on the same day. Yeah, that should be it for the system.